Now we're going to get into some of the core concepts behind object-oriented programming. And I'm going to start with interfaces, because in current C# development, interfaces are used a little bit more often than inheritance. Interfaces are when you have the same method signatures, but different results. And I got to start with a little warning. Most developers, while they can understand how to use interfaces in inheritance, do not get how to architect solutions with them for 3 to 5 years. It takes a while. It takes a lot of practice. It's not going to gel for a while. Do not panic. So what is an interface? An interface is a reference type that specifies a set of function members but does not implement them. It is an empty method signature. Think of an interface like a contract. Any class that you create that implements, that's a key word, implement, an interface is required to provide the code for the methods to make it work. Interfaces are a key concept in polymorphic design and unit testing. There's a couple rules for when we're working with interfaces. An interface may not contain any data members or static members. Additionally, an interface may contain some of the following function members: methods, properties, which we've gone over, events and indexers, which are a little more advanced and we aren't covering in this course. The declaration of these function members cannot contain code. We put a semicolon at the end instead of curly braces and a body. Most developers tend to prefix an interface with an uppercase I, like iClonable. Interface declarations can have accessors. So at the top, we can make an interface public, protected, whatever we'd like to do. However, the members of the interface are implicitly public, and as such, you cannot put an access modifier on an interface member. Don't worry, the next code sample, I'm going to show you how to set all this up. It's not as complicated as it sounds. But before I do that, I want to talk about the pillars of object-oriented programming. These are the things that separate object-oriented languages from other types of languages. There's 3 things that an object-oriented programming language has to contend with. The first is called encapsulation. How does the language hide the internal implementation details and preserve data integrity? We've already looked at how we can use properties and private fields and control access to our data. Inheritance is how the language promotes code reuse. We're going to get into that in a couple lessons. Polymorphism is how the language lets you treat related objects in a similar way. We're going to demonstrate that in the next lesson with a logging example. Polymorphism, poly, means many classes, and those many classes can be used by external classes without changing the code. It's very interesting. It's a very powerful concept. Encapsulation means that objects should hide their implementation details from the caller. When we call a method on a class, we don't want the calling classes to know what's going on inside it. It's none of their business. It allows developers to keep their code simpler to read and easier to understand. It also allows the developer to protect the internal state of an object. Sometimes we don't want other people mucking around with our data variables. We want them to have to access them through our methods and our properties. And here's an example. Imagine we have some code that spins up a file reader. A file reader reads files from the file system, and it's going to open a text file. myfile.open is a great use of encapsulation. We provided a path of a file we want to open, and it opens the file. We don't know how it does it. We don't know how it's accessing the file, what code is going on inside there. And as the developer, we don't really care. We just want the file to open so that we can do stuff with it. Properly encapsulated methods are very clean and very easy to use. Inheritance allows the developer to build class definitions based on existing definitions. This is often called extending a base class. I might write some code, and I'm going to have children that are going to consume my class, and they're going to use some of the existing functionality that I've already written, but they might extend it and do more interesting things with it. Inheritance is what we call an is-a relationship between types. A rectangle is a shape that is an object. In .NET, every class starts with system.object, and this is why every class has a toString method. ToString is defined on system.object. Polymorphism is when we allow a base class to define a set of members, a polymorphic interface, that are available to all their descendants. Virtual members are members that provide a default implementation that may be changed or overridden by derived classes. We're going to get into that in inheritance. Something that's virtual, you're going to write code that does something, but another class might extend or override your code and behave differently. An abstract member, which is kind of like what an interface does, provides no implementation and must be overridden by a derived class. So no code. It's a contract. You must provide this code. Like I said, this is a lot of big words. Don't worry about it. It's going to make more sense when I show you the demos coming up.